Hello everybody, welcome to my channel. Today we have a very good prompt for you guys called last stone weight. So this is a very good one, so make sure you pay close attention to the problem, right? So it says we're given an array of integer stones, right? Where stones of I is the weight of the eighth stone, right? We are playing a game with the stones. On each turn we choose the heaviest two stones, right, and smash them together. Okay. Suppose the heaviest two stones have a weight of X and Y, with X being less than Y, right? Less than or equal to Y. The result of this match is the following, right? So if X is equal to Y, both stones are destroyed, right? Okay. And if X is not equal to Y, right, it means that X will be destroyed, right? Because X is smaller, right? And the stone weight of Y, right, the bigger one, will be subtracting the weight of X from it, right? Okay. Because that's pretty much what they're saying here. Okay. So at the end of the game, there are at most one stone left. Okay, one stone left. Return the weight of the last remaining stone. If there are no stones left, return 0. Very, very important, very good problem, guys, right? Okay, so we just need to return the last weight, the remaining stone. Okay, so as you guys can see, we're given a bunch of stones, right? Each index represents the weight of a stone, right? That's what they said in the problem statement, right? So every stones of I represents the weight, right? So just make sure that we're on the same page, okay? So index 0, it means that the weight of the stone at that index is 2, right? Just like so on and so forth, guys, right? So so we return 1 because following this, right? So the first we get we combine the 2, right? The 2 weights, right? The 2 biggest weights, right? Because it says on each turn we choose the heaviest 2 stones, right? And we smash them together, right? So we're doing exactly what they're saying, right? That's what they're saying. We combine the biggest ones, 7 and 8, right? And then we combine them, and then now the array turns into 2, 4, 1, 1, 1, right? You see there are 2 ones, but we have an additional one because of the subtraction. 7 minus 8 minus 7, right? We get 1, guys. So we have this additional one that's not in the array, right? Okay. And now in this array now, right? Now we have this list. The next 2 stones that are the 2 biggest stones, right? 2 and 4, right? And that's why after we do that, guys, we subtract them, right? 4 minus 2 gives you 2, right? So and then we put the 2 here, right? And then we left with this list, and then we do the same thing to one of the next biggest ones, right? And then we do this subtraction, we get 1, right? So now there are 2 ones left, right? And we add an additional 1 again, right? So now we got 3 ones. And then after we do that, we do this 1 and 1, get a 0, right? And then we're left with only this one here. And that's the last stone standing, right? So we return 1, right? That's kind of how it was derived. This one, we only have this one, right? We return 1 because that's the only stone in there, right? So by default, we just return that right away, guys, right? So nothing to compute there. So how do we solve it, guys? Are we fully able to understand the thought process? How do we go ahead and solve it, guys, right? How do we solve it? Okay. Yeah, so we need to kind of think. So what I'm thinking here, guys, right? Well, how can we do it? So we can introduce, so let's see, we need to find a way to return the last remaining stone, right? Somehow we're gonna need to do kind of simulate the behavior, guys, right? Of the thing, right? So we need to loop through this somehow, right? And at every iteration to capture the 2 biggest ones, right? Do the subtraction, right? And then we add it to the list again, guys, right? Okay. How do we do that? That's kind of the important thing, right? And that's how we need to come up with. So somehow we need to do that. Okay. Okay, so we can just start with a list, right? You know what I'm saying? So it can't be a static array, right? It has to be some sort of a dynamic list that I'm thinking of, right? A dynamic list. And so somehow we would need to sort it first, right? We can start off by sorting the inputs, right? So that we can easily get the second, like, the biggest one and the second biggest one, right? By just either getting that index 0, index 1, or the numbers minus 1 and numbers minus 2, right? The length of it, the array, right? Yeah, depending how we do the sorting, right? So we could do the sorting that in a way that all the big numbers are towards the front, right? So we can do 0 and 1 easily, okay? And then we sort it, right? And then we would get some sort of thing like, let's say we were to sort this input, it would be 7, 8, 7, 8. Next thing is 4. Next one is 2 and 1, 1, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, we got the same amount of numbers, so it looks correct. And every time we just get 7 and 8, guys, right? We get the biggest ones here, right? 7 and 8. And we do the subtraction, right? So after the subtraction, so we take those two out, right? So now the array will come like that, the list, because everything's still sorted, right? And then we do the subtraction of the two numbers we just removed, and then we just add it in there, right? Pretty simple, because that's what they're saying here, guys, right? That's the operation that we do, right? If it's not equal to y, right? If the two numbers are not the same, then we do the subtraction here, right? And then we re-add it to the list again, right? That's what we need to do, okay? So now that we have that, right, we keep doing that, right? 4 minus 2, right? So this example, right, it might say, oh, that might work, right? But it's not gonna be too good, guys, right? Because it's not gonna be good because, guys, right? It's very convenient that we could just add like when we do the subtraction, right? The numbers are small and they can be easily placed at the end, guys, right? So it's right. But let's say we had some weird numbers, right? Let's say we had like 17, right? 17 and 10, right? And 17 and 10, but right, 17 and 10. So we do the subtraction right now. It's 7, right? We can't just append it at the end, guys, right? Because so now it would look like that, right? 4, 2, 1, 1, right? And then we can't just put 7 at the end, guys, right? Because 7 is the biggest one, so 7 should be at the top, right? So it means that we would need to sort it every time as well, guys, right? I know that sorting costs us n log n, guys, right? So we would need to sort it every time as well, right? The input, so it doesn't work, right? Because we know that it needs to be dynamic in a way, guys, right? Because when we add it to the data structure, right? Let's say this list that we're using, right? It's not automatic, right? It's not, it'll just append it at the end, guys, right? Right? This 7 should be at the beginning, right? So how do we so the data structure that we end up choosing, right, has to be able to fit that able to handle those kind of cases where we can put it in the data structure, right, and it can dynamically rearrange itself so that the big numbers are always easily accessible, right? Easily accessible, and I can just pick them up, right? By just calling the whatever API that I'm using, right, to get the biggest two, guys, right? So it needs to be dynamic. So as you guys can see with that type of constraint, right, the data structure that comes to mind that can easily allow us to do that, right, get the maximum of something, right? If you want to get the maximum X numbers, maximum K numbers, right, the data structure of choice that comes to mind is usually a heap, guys, right? A heap data structure is going to allow us to get those things and good time complexity, guys, right? So it's kind of important that we do that, right? So we know that adding stuff to the heap, right, and removing stuff to the heap is going to cost us log n, right, which is a little bit more efficient than having to sort every time, right? Every iteration, right? It's not going to be too efficient that way. So the heap, we decided to choose a heap because when we add stuff to the heap, right, and it's gonna automatically heapify, reorganize itself so that I can have access to the big elements, right, at the top. I can just take them out and do the subtraction at every iteration, guys, right? Because without that, if we were to use the list, right, well, we add numbers to the list, we need to sort it every time, right? So that it can be sorted, guys, right? So that's kind of the improvement that we're doing, which does make sense, right? So makes sense of the thought process with our heap problem in this channel. So if you're not too familiar with that data structure, I highly suggest you check out those other ones. We go into a lot of detail, so a lot, detailed walkthrough. And right, so I'll probably have a playlist that you guys could go check out. Okay, so the code will be relatively simple. So we'll use a priority, right? Okay, so the heap is gonna, so it's a integer, so it's called a max heap. Sorry about that. Okay, we have our heap rate, so we just need to pass in the comparator, right, function. So we want it in reverse order, right? Max heap, right? So after we do that, right, we just go ahead and do a linear loop and add our stone into stones into the heap, guys, right? Okay, we add that in there. So now our heap is ready, right? So now we're gonna just simulate the scenarios, guys, right? So every time, right? So we're gonna have, so while we are, the heap, right, is greater than 1, right? Well, the heap's greater than 1, right? Because it says we want to return the last stone standing, right? So that's why we're saying we have this thing here. So what we're gonna have here is called heaviest stone, right? It's going to be max heap that pole, right? So we get the heaviest stone out of the heap, guys, right? That's what we're doing here. And then we also need the second heaviest, right? Because that's what they're saying, guys. Every turn, right? Every iteration, pretty much, are saying to get the two heaviest stones and smash them together. So it's exactly what we're doing here, guys. So second heaviest stone. Okay, so equal to we just get the second one here. Okay. So we get that, and we're gonna do diff, the difference between the two, which is gonna be the heaviest stone minus the second heaviest stone, guys, right? And then we're gonna do a check, guys, right? If the, I can just put it in there, all right? If statement. Okay. So if the heaviest stone is not the same as the second heaviest stone, right? We do that because they're saying if they're the same, guys, right? They're both will be destroyed, right? So there's nothing to do, right? We don't need to add 0 into the heap again, right? So if they're not the same stone, right? They don't have the same weight. I meant to say, right? Same weight. Yeah, we could go ahead and add their difference into the heap, guys, right? The max heap. Okay. And we keep doing that, right? Until, right? You're gonna come to a point where we have 1, right? Then we would exit, guys, right? And then we do a check here, guys, right? If the max heap is empty, right? If it's empty, then we can send the return 0, right? If not, right, then we're gonna do max heap that right, get the last element in there. Okay. Yeah, so it's pretty interesting problem. So we just have a max heap what we use, and we keep getting the two heaviest stones, and then we calculate the difference and we re-put it back in the data structure, right? So that it can reorganize itself, and then we keep doing it until there's only one element, and then we return that element, right? So let me know if everything makes sense, guys, right? We started off with talking about using just a simple list, right? And then we kind of saw that the list didn't really wasn't the most efficient one, right? Because we got to sort it every time, right? And then that's why we improve it to use a heap, guys, right? Because of the dynamic reorganization of itself, right? Hipify of the elements, right? So it gives us access to those elements pretty easily, guys, right? Without having to sort it. And yeah, it looks good to me. So everything passed. So if you guys understood everything, in the comment section. If you're new here, make sure to subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.